All right, welcome back. We're going to continue our discussion of properties of real numbers, and we're going to look at graphing numbers. So we're going to graph each of the numbers on a number line. We're going to start off with the square root of 5. So if you don't actually know what the square root of 5 is from the top of your head, we're going to go to our calculator here, and turn the calculator on. And then what you'll do is you're actually going to hit Control Square, and it'll actually make the square root sign appear on your calculator. And then just type the number 5 in there and hit enter. And you'll see that it's 2.23607. If you're using a different calculator of any sort, by all means, you could just do the square root of 5 on your phone or any other calculator that you might have. But you see that's 2.23. So we're going to come over here to about 2, and not go quite halfway, but maybe halfway between the halfway point. We're going to put a dot right there, and we're going to let that be the square root of 5. All right, then we're going to do negative 1.4. Again, this little line here represents repeating. So that just means it's negative 1.444444444, which is pretty darn close to negative 1.5. So we're going to put a decimal about right here and call that negative 1.4 repeating. And now we have 1/3. If you don't know 1/3 by heart, again, on your calculator, you can do 1 divided by 3. For these calculators, if you just do Control Enter, it actually turns it into a decimal for you. Most other calculators naturally turn it into a decimal. But you see it's 0.33 repeating. So that would be about not halfway between 0 and 1, but a little bit less than halfway. So then we're going to put our decimal or dot there and call that 1/3. All right, so let's look at part B. The square root of 17. Again, go through the same process in your calculator. Type in the square root of 17. Again, the Control X squared. I'm going to type in 17 and then enter, and I see it's 4.12311. So I'm going to come over here to a little past 4, and that's going to be my, bad little dot. It's going to be the square root of 17. And then I get negative 4.66666 repeating, so that's going to be a little past negative 4.5 on this side. So there we have negative 4.6 repeating. And then we have 2 1/4. Well, if you don't know what that is in your calculator, you can type 2, and then to make a little fraction just like that, you can actually hit Control Divide. I guess in the calculator you're going to have to do use the parentheses, and now Control Divide. There you go. And then you have your 1/4. Hold on now. Let's try this direction then. All right, so 1/4, 2 1/4. What you can do, what this indicates when you have a mixed fraction, this just means 2 plus 1/4. Then you can figure out what 1/4 is, or just type that part in your calculator. This doesn't actually indicate multiplications 2 1/4, so that would actually be 2 plus. Now we should be able to do the Control Divide. There we go, 1/4. And we see that it still gives us a fraction. In other calculators it won't, but just do Control Enter, and it says it's 2.25. So we can come over here to 2.25. We can write our response right here. And this right here would be 2 1/4. So let's look at part C now. So now we got the absolute value of negative 4. That's what these two bars mean. That just means absolute value. And if you remember, the absolute value is the distance from 0. So how many numbers is negative 4 from 0? So let's count it. So that's 1, 2, 3, 4. So the absolute value of negative 4 is actually a positive 4, because distance is always measured with positive numbers. You can't have negative distance. So the actual point of absolute negative 4 is actually on positive 4. And we got 12/5, which is that's an improper fraction. If you don't know it, you can type in your calculator 12 divided by 5. Control Enter, and we see it's 2.4. So So we can go about halfway between 2 and 3 and write our fraction 12 over 5. Now we have negative pi. Well, if you don't know what pi is, 3.14, everything can be done in the calculator, so you can get the negative. The pi symbol is actually down here next to the h. Just hit that and then select the pi option. And now you have negative pi, which is negative 3.14. So again, if you don't remember what pi is, you can go about this route as well. So we're going to go about negative 3.14, which is about a little past negative 3. And then that's going to be our negative pi. All right, so let's move on. And you can pause, rewind, fast forward at any rate that you would like. All right, so our next example is ordering real numbers. Which one is greater than, less than, or equal to each one of these? Well, we have 6.25, super straight and easy, but we might not know what the square root of 26 is. So in our calculator, we'll do Control x squared and actually type 26 in there, and we see that it's 5.0999. So we'll write that out. So 5.099 and some other numbers. Regardless what the other numbers are, which one is greater? Hopefully you're saying 6. Think of it like money. Would you rather have $5 in change, or would you rather have $6 in change? And if you remember from elementary school, the alligator or Pac-Man always eats the bigger number. So I'm going to have the open part going towards the bigger number. All right, so let's keep going. When you have a whole bunch of decimals here, you're going to go from left to right. So they both have a 2. That means they're still the same. But then the second number is a 2, where the second number here is a 3. At that point, the 3 made it larger than 2, so this number, in fact, actually just became larger than this one. Even though this one has more decimals in it, you just go from left to right looking at each number. So again, we're going to make the alligator eat the bigger number, which is this number here. All right, so again, this is 0.6 repeating, which is also considered as 0.666666, so on and so on. So we need to figure out what the square root of 4/9 is. So in our calculator, we will do Control x squared. To make a fraction, you can either just do 4 divided by 9 or Control divide 4 over 9 and then hit enter. And it says it's 2/3. Well, we can always do Control enter to make it a decimal. So that shows it to us as 0.666. Eventually it becomes a 7. So what that 7 means, it actually rounded, but it's actually a repeating number as well. So we see that they both have the exact same amount of numbers, so therefore they must be equal to each other. All right, go through the same process here. If you don't know these numbers, well, real quick, if you took the square root of 0.09, that is a smaller number than 0.1, because you got to think this is 9 cents. This is actually, add a 0 here, this is actually 10 cents. So this one is smaller than that one. So the square root result should end up being larger than this one. And since this one will be larger, that negative, the bigger the negative, the smaller it becomes. So in fact, this number should be the greater number. But if you're not sure of that, again, you can just type in your calculator, negative, Control x squared, and type in 0.09, and you get negative 0.3, and then do the same thing to the other one. So that's negative Control squared 0.1. Hit enter, and you see that it's actually negative 3, what was it? Oh, 0.316. 0.316. So again, you see that because of that 1, it became larger than that, but because it's a negative, the bigger the negative, the smaller it is. So you rather, in this sense, would you rather owe someone 30 cents, or would you rather owe someone 31 cents? So you rather owe 30 than 31, so this becomes greater. All right, so we look on to E. We see 1 is pi, and we see 1 is 3.1415. When you're like, all right, well, that's what pi is, because that's what we've rounded it to for so long, they must be equal to each other. But one thing I want you to caution on is you actually type pi here and hit enter, you get 3.159. Well, pi is actually a number that keeps on going on and on and on. So if you're going to compare it to a number that stops, then pi itself will then become greater than, because the next number for a decimal that stops is actually the value of 0. And this one actually keeps on going and makes that value 9. So therefore, pi in this situation would be greater. All right, here's a little tricky one to see. I've been paying attention this whole time. Let A, B, and C be real numbers such that A is less than B and B is less than C. So remember, real numbers are just numbers that are not imaginary. Right? So that's your decimals, that's your whole numbers, natural numbers, all your rational numbers, and irrational numbers. That's true at the same time. So how do A and C compare? Well, if A is less than B, but B is less than C. So let's do a number line. So A, let's call this A, it's got a starting point, is less than B. So B must be on the right of A. And B is less than C, so that means the C needs to be on the right of B. So just looking at this number line here, we can tell that if we're comparing A to C, A must be less than C. Okay? Since A lies to the left of C, using logic. All right, make sure y'all get that. Let's move on to the next one. All right, so here's all your properties of real numbers. All right, so again, you have closure. So A plus B is a real number. A times B is a real number. So basically what closure means is if I add two numbers together or I multiply two numbers together, I get real numbers. So for instance, if I take 2 plus 3, I get 5. And if I take 2 times 3, I get 6, which are both real numbers. Okay? Commutative just means if I take 2 plus 3, that should equal the same thing as 3 plus 2. Same thing with multiplying. 2 times 3 should be the same thing as 3 times 2. The associative property just means wherever I put the parentheses, this shouldn't matter because it should all answer the same thing. So if I say 2 plus 3, parentheses, plus 4, right, so that would give me 5 plus 4, which is 9. Over here, if I just move the parentheses over there and say 2 plus parentheses of 3 plus 4, well, if I do 3 plus 4, that's 7 plus 2, which is 9 again, which works out. Same thing with multiplication. If I do 2 times 3, and then the 4 on the outside, and then over here now I put the 2 on the outside, and I do 3 times 4, well, I should get to the same thing. 2 times 3 is 6, 6 times 4 is 24. Over here, 3 times 4 is 12, 12 times 2 is 24, so you know it works out. The identity just means if I add 0 to the value, I should get that number. So if I say 2 plus 0, it better be 2, right? Vice versa, if I say 0 plus 2, it should still say 2. Multiplication is instead of adding or multiplying by 0, you would actually multiply by 1. If I say 2 times 1, I better get 2 out of it. And if I say 1 times 2, I'll also get 2 out of it. By the way, those dots here mean multiplication. Inverse. So if I take a, we talked about this when talking about opposite. If I take 2 plus negative 2, that means I have $2. I spend $2. I should end up with nothing. Over here, it's a little bit different. It deals with the reciprocal. So that would be, so this again, this is the reciprocal. So if I take 2 times 1 over 2, if I type that in my calculator, I'll actually get 1. It does not work if A is 0 because, again, you cannot have 0 on the bottom of a fraction that is undefined. The distributive property just means that if I have a value here, I can distribute it, and it should look like this. So A times B is AB plus A times C, which is AC. So that works out. Okay? So that's just explaining what all those properties are. All right, so using that, let's look at example 4 here. Identifying properties of real numbers. Which properties is illustrate. So we don't have to solve anything, but just looking at the notes you just saw, or have on your notes right now, which property is this? So think. We have parentheses, so it can either be associative or distributive. So if you think it's distributive, make sure the number is next to the parentheses and there's no operation in between. So since there's an operation in between, it will not be distributive, it must be associative. And of course, because of all the adding, you can go further and say this is the associative property of addition. Okay. So here we got parentheses again, but now I have a number next to the parentheses with no operation, so this now must be the distributive property. And doesn't have any category where it has to just do with adding or multiplying or anything like that. It's just all distributing. And now we look at this one. We have 6 times 1 minus 2 and 6 minus 2. So what we see is we have something that's being multiplied by 1. Right? So we come over here, and the only thing that we saw multiplied by 1 must be the identity property. Ooh, too far. The identity property of multiplication. All right, so let's move on to the next one. So looking at example 5, we find it says find the opposite and reciprocal of each number. So of course, for it to be opposite, all you do is just put a negative in front of it, or if it is negative, make it positive. So this will just become negative 24, negative 5 and 2/3. Of course, if you ever want to pause this and try to do it yourself before I do it, that's a good idea as well, to see if you really know what's going on. Because of that negative, that does become positive. And then that just becomes a negative square root 2. So that's all you have to do for opposite. Now reciprocal, for at least whole numbers, all you got to do is put a 1 on top. So that's just going to be 1 over 24. Now, because this is a mixed fraction, what you're actually going to do is actually convert that into an improper fraction. Now the way you do that is you're going to take the whole number times the denominator, and you're going to multiply it. Right? And then you're going to take that result and you're going to add it to the numerator. So we say 5 times 3, which is 15, plus 2 makes it 17 over the original denominator, which is 3. So if I wanted the reciprocal of that, all I got to do is just flip the fraction. All right, so that just becomes 3 over 17. Now this one is not a fraction, so we need to convert that into a fraction. So if you look here, again, it's still negative. This is the tens place. This is the hundreds place. So since the 1 is in the hundreds place, I know on the bottom of my fraction it is going to be 100. And then you take whatever that value is and just put it on top. So 0.01 is actually 1 over 100. So if we wanted the reciprocal of that, we just flip the fraction, and now we got negative 100 over 1. But do I need a 1 on the bottom? Well, your answer should be no. So you can actually simplify this, and it'll be negative 100. All right, same thing over here. Now this is a square root of 2. There's no need to do anything really with it. Realize that this is an irrational number, but a rational number can still be written over 1. So if I wanted to flip that, it would simply be 1 over the square root of 2. Now later on, you're going to learn that we cannot use square roots on the bottom. So we'll do a thing called rationalization, which will multiply both the denominator and the numerator by the square root of 2. What that will give us, if you just multiply straight across, 1 times square root of 2 is square root of 2. And in your calculator, if you do square root of 2 times square root of 2, you'll see that it actually gives you 2. So the point of rationalizing here is to actually get rid of the square root. So if you actually multiply two of the same square roots together, the same numbers inside, you end up with just that number without the square root. Alright, so last slide. Example 6. Simplify each expression. Well, what's the absolute value of 9.2? Again, it's a positive number. How far is it away from 0? Well, your answer should just simply be 9.2, because it is that far away from 0. Now, here's a little bit different. You want to do what's inside the absolute values first. So the absolute value of negative 2.3 should be 2.3, which is a positive version of that. But then you need to multiply your negative 0.4 there. And if you don't know how to do it by hand, of course you go here in the calculator and you'll do negative 0.4. You can do the timed or parentheses. Since I wrote a parentheses, I'm going to keep parentheses. 2.3, hit enter, and you actually get negative 0.92. Over here, 5 minus 12. So if we keep the absolute value and just work inside, 7 minus 12 is negative 5. And then we start, okay, what is the absolute value of negative 5? Well, again, that's 5 numbers away from 0, so it should be 5. Now we work it out the parentheses. So first thing it says, what's the absolute value of 7? Well, that's 7. What's the absolute value of 12? Well, that should be 12, both positive versions of themselves. Then we do 7 minus 12, which you just did in our calculator, and that actually ends up being negative 5. Alright, so don't forget to post your questions or comments on what you learned in these two videos. Alright, see you in class.